All right, so our first step for the 8.4 boundary point and interval chart example from our test is to determine where f of x is greater than g of x. So f of x is our function in red, and g of x is our function in blue. We can go ahead and write those in. So x cubed minus 3x squared minus 2x plus 4 is greater than 6x squared minus x plus 4. So we have this inequality, and now we want to equate to 0 because we are trying to solve for our boundary points. We can't do anything until we've equated to 0. So x cubed minus 3x squared minus 2x plus 4. Now we move everything from our blue function over to the other side. So subtract 6x squared plus x plus minus 4 is greater than 0. Okay, so now we want to collect our like terms. We have no other x cubed functions, but we have some x squared, we have some x, and we have no variables attached to some of them. So we're going to go ahead and collect our like terms. And then we have our constant, no variable attached. Rewrite our x squared. Now, negative 3x squared subtract 6x squared gets us negative 9x squared. Then we have negative 2x plus x gets us negative x. Then we have plus 4 and minus 4, which gives us no constant whatsoever, all greater than 0. So now that we have everything equated to 0, we want to try and solve for x. First, we can see, are there any greatest common factors? Well, all of these have x in them, correct? So we can go ahead and pull x right out to get us x squared minus 9x minus 1, remember, because that is a 1x, is all greater than, won't load there, is all greater than 0. Okay, now, is this at all factorable? Can we solve for where somewhere that is equal to 1 can get us 9? Absolutely not. Factors of 1 cannot get you 9 because that's just 1 times 1. So we will have to use the quadratic formula. We know the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So b, here, let's just write b, or start with a. A is 1, b is negative 9, and c is negative 1. Now we're going to go ahead and sub all of that in. X is equal to negative 9 plus or minus the square root of negative 9 squared minus 4 times 1 times negative 1 all over equal sign is equal to all over 2 times 1. So negative 9 is just equal to 9 plus or minus, remember, square root of, we have 81 minus, so 4 times 1 times negative 1 gets us negative 4. Negative times negative 4, so we're going to end up adding 4, all divided by 2. So just to save room, I'm going to re-erase what is in under that square root and rewrite it. So 81 plus 4 gets us 85. And now we have two ways of going with this. We have x is equal to 9 plus root 85 divided by 2, and x is equal to 9 minus root 85 divided by 2. Okay, so we now want to solve for x on both sides. Unfortunately, we will have to approximate, but we're going to do the best that we can. So, root 85 is equal to approximately, we'll keep three significant digits, 9.22. Oh, that's not a root anymore. Do that for the same side, minus 9.22 divided by 2. So, we now have 9 plus 9.22, 8, which is 18.22, divided by 2 to get us 9.11. Remember, approximately, because we've rounded now. 9 minus 9.22 gets us negative 0.22 divided by 2 to get us negative 0.11. So we now have our boundary points. So one thing that we should always keep in mind, right back up where our original equation is, you can notice that we have an x here. We solve for this part of the equation, but we also have a third boundary point here. X is equal to 0. So not only do we have to zoom back out and go over here, we can restate our boundary points of, wait, those are green. Boundary points are, we have negative 0.11. We have our 0, key important point, and our 9.11. Okay, so that's super, super important that we always keep that in mind. That yes, we solve for the boundary points in those brackets, but we also have that x outside of the brackets. So we've restated our boundary points. Next, we have to solve for where f of x is actually greater than g of x. We use our interval chart. So we can go ahead, draw our chart. So remember, we have 3 boundary points, which means we're going to have 4 intervals. Keep doing that. Okay, and we're going to rewrite our original equation that we had solved for once everything was equated and our GCF was taken out. So that, buddy, was x squared minus 9x minus 1. Okay? So, in each of our intervals, we are going to hit each of our boundary points. So our first interval, I'll zoom on in, just to be able to write this a little bit better. First interval is going to be negative infinity all the way to our first boundary point of negative 0.11. Brackets around that. Our second boundary point is going to be from negative 0.11 all the way to 0. Then we have from 0 to 9.11 and from 9.11 all the way to infinity. All right, now we're going to pick a point or a number from each of these intervals, and we are going to set that into our equation to see if we get a negative or a positive number. So from this negative infinity to negative 0.11, easiest number to pick, negative 1. From negative 0.11 to 0, easiest number to pick is probably negative 0.1. From 0 to 9.11, we're going to choose number 1. And from 9.11 to infinity, we're going to choose 10. Those are super, super easy numbers to work with. So, negative 1. So we're going to solve for what's in the brackets first and see if what's in the brackets gets us that negative number with negative 1. We have a negative outside. Squaring that negative gets us a positive number of 1. Subtract 9. 1 subtract 9 gets us negative 8. Negative 8 subtract 1 gets us negative 9. So we are back at a negative. 2 negatives make a positive. So overall, that interval is going to be positive. We can move on to the next one, negative 0.1. So we know what's outside is going to be negative. What's inside is going to be, when we square it, it's going to be positive. Let's get our calculator out. 0.11 times 0.11. So we get 0.0121 minus 0.0121 minus 9 times 0.0 or 0.1. So it gets 0.09, 0.0121 minus 0.9 minus 1. Overall gets us a negative number. So again, that interval is going to be positive. For our next interval, 1, we know that this is going to be positive. Now let's see what's in the brackets. 1 times 1 is 1 minus 9 minus 1 gets us a negative 9. So overall, this interval is going to be negative. Last but not least, 10. So outside, we're going to have that positive 10. Inside the brackets, 10 times 10 is 100 minus 90 minus 1 gets us a positive number. So again, overall, this interval is going to be positive. Cool, so that was super easy. We now have our positive intervals. Are we looking for the positive or the negative? For that, we have to go back to our original data. We are looking for where f of x is greater than g of x. That greater than g of x means we're looking for the positive intervals. If it was less than g of x, we'd be looking for the negative intervals. So back where over this, right over here, f of x equals greater than g of x, we're going to write a little note. Positive intervals. Okay, because that's greater than. Let's let that load. So, all that's left is our therefore statement. Because we know our positive intervals, we can circle those right here. These ones. So, therefore, f of x is greater than g of x when x is an element of our first interval, negative infinity to negative 0.11, and when negative 0.11 to 0, and from 9.11 to infinity. Okay, so those are our intervals where f of x is greater than g of x. That is the entire question with boundary points and inequalities of combined functions. It should be easy enough to figure out.